going to continue with our just remembering how to do stuff. Okay. We are going to talk about vertex form today, and we're going to talk about factoring quite a bit. I want to touch on the fundamental theorem of algebra. They use a lot of words here to say something, and I mean it's fundamental. Fundamental means basic, okay? And the fundamental theorem of algebra basically says every equation has a solution. That's it. That's what it says. Yeah, it's pretty basic. If you have an equation, there is a solution. Not only is there a solution, but there's a solution for every power. So if you have a linear equation, there's one solution. If you have a quadratic, there's two. If you have a cubic, there's three. If you have a solution, or if you have an equation that goes for the 50th power, you should be able to find 50 solutions. That's what the fundamental theorem of algebra says. Every equation has a solution. It may not all be real, but it has. Okay? Now, let's look at the next page. What does the form tell me? All right. Look at these quadratic functions in vertex form. What's the vertex? Like, what's the vertex on A? Three, -4. H, K. 3, -4. Does it open up or does it open down? It opens down, okay? Knowing those two things, just looking at the equation, am I going to be able to determine if this has real zeros or imaginary zeros? Is that enough information? Where's 3, -4? What quadrant? The fourth quadrant. It's down here in the fourth quadrant. In which direction does it open? So is that enough information to know if it has real or imaginary zeros? Yeah, it is. Is that ever going to cross the x-axis? Can I be in the fourth quadrant opening down and still come up here somehow and cross over? No. So this has imaginary zeros. I know it has imaginary zeros because vertex is in the fourth quadrant and it opens down. How about B? What's the vertex on B? 3, -4. Same one. Which way does it open? How do you know it opens up? 2 is positive, okay. Real zeros or imaginary zeros? Real. How do you know? Yeah. The vertex is in the vertex in quadrant 4 and opens up. How about C? What's the vertex? Real or imaginary? Real. Not only are they real, where is this vertex? On the x-axis. The vertex sits on the x-axis. So this is one real double root. It's actually sitting on the x-axis. Okay, let's look at the chart on page 2. Try to complete the chart with your partner. I'm going to give you about a minute. And then we're going to talk about factoring. All right, so if it is above the x-axis and it opens up. It has 0 intercepts, 2 imaginary roots, 2 imaginary zeros. What if it's above the x-axis and it opens down? How many x-intercepts does it have? 2. Okay. Are they real or imaginary? 2 real. And 2 real zeros. Okay? Below the x-axis. If it's below the x-axis and it opens up, how many x-intercepts does it have? 2. Means it has 2 real roots, 2 real zeros, right? Below the x-axis and it opens down. How many x-intercepts does it have? 0. So it has 2 imaginary roots, and 2 imaginary zeros. Alright, if it's on the x-axis and it opens up, how many x-intercepts? 1. Okay? That's 2 real roots, though. It's just a double root. That 1 counts twice. And the same thing for the zeros. You still have 2 real zeros. What if it sits on it and it opens down? Yeah, same thing. 1 with 2 real roots and 2 real zeros. Talked about getting the roots from quadratic formula yesterday. Today we're going to talk about getting the roots from factoring. I'm not sure if you remember how to factor. Do you remember how to factor? No? Do you remember that there's this thing called factoring? No? Okay. Awesome. This should be fun. Okay, when you're factoring, you're trying to find out what 2 things multiply together to make this particular equation, particular quadratic. We're actually going to go back to one that we did yesterday with quadratic formula. Okay. Alright, so A, B, C. That's still A, that's still B, that's still C. Just like it was yesterday. When I factor, I just call it X factor. I make an X, and at the top of the X is A times C, and at the bottom of the X is B. So A is 1, and C is negative 14, so what's A times C? Negative 14, and B is negative 5. So I then, on either side of the X here, I pick 2 numbers, that when multiplied give me AC, and when added give me B. Now, sometimes these numbers don't just fall out of the sky and land on your paper. Sometimes you have to actually list the factors of the number to get what they are. This one's pretty easy. It's pretty easy to think of two numbers that multiply to equal negative 14 and add to be negative 5, right? What are they? Negative 7 and 2. So right there, I circle them so I know what I'm looking at. If they don't fall out of the sky and land on your paper, it's really easy. You pick up your pencil and you start listing the factors. Negative 1 and 14, or 1 and negative 14. Negative 2 and 7, or 2 and negative 7. Until you find the two that give you the sum that you're after, okay? You do have to do this sometimes. Now, I'm going to rewrite this problem, and instead of writing, that should be an x. Instead of writing 5x, I'm going to write negative 7x and 2x. X squared minus 7x plus 2x minus 14 equals 0. So look closely at that. Did I change the value of the equation at all? No, because what's negative 7 plus 2? Negative 5. It's like you got 4 quarters for $1. It's the same amount, it just looks different. Okay. Once I get to there, I group these two together, and I group these two together, and I factor what's there. What can I bring out of both of these terms in the front group? What common factor do both of these have? What? They both have an x. And what's x squared divided by x? What's negative 7x divided by x? Right? Over here, in this back end, what factor do both of these have in common? A 2. What's 2x divided by 2? What's negative 14 divided by 2? Alright, so you end up with something that looks like this. Notice how both of these are exactly the same. If those aren't exactly the same, you've done something wrong, and you need to erase it and start again. These should match exactly. Because what we're looking at here is FOIL, distributive property, whatever, backwards. See, this started out as x plus 2 times x minus 7. X times x minus 7, 2 times x minus 7. That's what we're looking at. These are our factors. Those are the factors. Okay? These are the factors. Right there. I'm going to let you catch up. I'm going to take it one step further. But I want you to be caught up with where I am. Alright, now the zero product property, because see, these equal 0, right? And how does something get multiplied to equal 0? One of them has to be what? Yeah, one of them has to be 0. You can't just multiply something and get 0. One of them has to be 0. So the zero product property said that this equals 0. See, I did the work without the 0, but there's one there. That means that x plus 2 equals 0, or, and, either one, x minus 7 equals 0. So x is negative 2, x is a positive 7. Those are our x-intercepts, right there. Negative 2, positive 7. If you look on your work from yesterday, your notes from yesterday, we did the exact same problem. We got that exact same answer, but we used quadratic formula. This quadratic formula always works. Factoring does not always work, but you have to know how to factor. You must be able to factor. Alright, let's try another one. Can I move this one? Okay. 2x squared plus 2x minus 12. That's not the one I want to do. Ignore that. 2x squared is right, but it's minus 3x plus 5. Minus 3x minus 5. What's A times C? Negative 10. What's B? Alright, what are two numbers that when multiplied give me negative 10 and when added give me negative 3? Negative 5 and 2. I'm going to replace 2x squared minus 5x plus 2x minus 5. Alright, that's my next step. Separate. Anything come out of this front group? X. What's that going to leave me with? Alright. Does anything come out of this back group? No. But I gotta have something. So what do I divide by that doesn't really change it? Right, so I'm going to put 1. Do they match? Yeah. So that means that at one point in time, this was x plus 1 times 2x minus 5. Zero product property tells me that x plus 1 equals 0. 2x minus 5, 0. X is negative 1. X is 5 halves, 2.5, whatever. Those are my two answers through factoring. Hey, do you somewhat, sort of, kind of remember factoring at some point in time? Yeah? Okay, so we just need some practice on it. Look on pages 205 to 206.
I'm just